Okay, I believe you guys already scanned the QR code. Okay, let's start our course by looking at uh, the results from yesterday feedback. Okay, so the question is about the rational functions, and um, if we look at the questions, this is the question. You have a function r of x, and we have x squared plus x over x plus 1 to x minus 4. Okay, if we look at this, and then we probably maybe thinking that, okay, maybe these functions have vertical asymptote and horizontal asymptote. And vertical asymptote, if we look at, we have this is, when it's 0, then x is minus 1. Oh, this is vertical asymptote. And then when we look at, there is 1x squared here, and there is nothing here, or maybe this is also y equal 1. So the first thing is we need to change a little bit the functions. Okay, we need to reshape the functions. For example, we're going to look at the functions in this way. Okay, and we know that this is the common factor, right? The common factor. So if we have a common factor in the functions, probably we will have a whole in that function. So x equal 1 is a whole, not vertical asymptote. Okay, this is in the previous slides in yesterday's course. I think in the last sections, I told you about the common factors. Okay, and we have another one here that is x equal 2, that will be our vertical asymptote. Okay, or we can also rewrite this and become x and then 2x minus 2. So when x is 2, the functions become very, very large, right? Because it's divided by 0. And then we can also change the form and make it into this. Okay. If we look at this function here, we look at the highest degree of the function itself. This is 1, right? And this is 2, right? So we will have half. So y equal half will be our horizontal asymptote. Okay, this is based on what we have done in the last sections yesterday. Okay, or if you want to be more precise, you can divide by x squared. This will be approaching 0, approaching 0, approaching 0, and we will have half. So B and D are true. So B and D. Okay, next question. I believe this is not too difficult, as long as you can divide the polynomials with the other polynomial here, and we get the notions that this will be x plus 8. Okay, and you don't really need to finish until this statement here, the remainder and the other, as long as you get this mx plus b as long as you get this structure, you will know that this will be our slant asymptote. Okay? So we will have x plus 8 is the slant asymptote. Okay. So congratulations again, Scarlett, for winning the game. Okay. Okay. Any question from these two? I hope not. Right? It's not too difficult, right? But you need to remember this. Okay. Remember about the common factors. Okay. Remember about the common factors. Okay. If you have a common factors, the common factors will make the graph. There will be a hole in the graph, okay? Not the vertical asymptote. Okay? Because if you have -1 here, the functions will become 0 over 0, in which if you learn the calculus part, that is the we call actually the indeterminate forms. Okay, indeterminate forms. Later in the calculus we will learn. Okay, now there's one last section about the still polynomial. Last section in the polynomial, but I think this last section is not too complicated. This is about the polynomials inequality. Okay, so we have learned before the inequality. Okay, to get this idea of polynomials, let's just try to go to example. Okay, let me go through the some functions or some polynomials. Uh, okay, the question is just solve the inequality. Okay, now to solve this, okay, in terms of polynomial, the idea is still the same. Put all into the same sides like that, and you will have this 0 here. It always makes the some one of its side is 0. For this case, a right side is 0. Okay, how to factor? Remember, you have 2, you have 6. We may have a factor of 6 divided by factor of 2. Factor of 6 is 1 plus minus 1 plus minus 6 plus minus 2 plus minus 3. This one plus minus 1 plus minus 2. So you will have this plus minus 1 plus minus half plus minus 6 plus minus 3 plus minus 2 plus minus 3 over 2. Yeah. 3, 2, 2. Yeah. At least we have the 6 terms that we are going to evaluate. You can also try the Descartes rule if you want to look maybe how many change in or how many zeros we have, positive, negative, right? So first we are looking at 1 and 2. So probably we have 2 positive 0 or 0 positive 0. And maybe we can also look at so if this is px, okay, so if we have p negative x, we can have still oh, we just have 1. So certainly we will have 1 negative 0. So we will maybe start with the negative. Okay, let's start with 2, 1, negative 13, 6. Let's start with the synthetic division. Divide by maybe negative 1. I believe this will be not okay, right? So maybe we can change another one. So negative 1 is not, so maybe negative 2. Also not correct, not our zeros. So this is how you actually finding the zeros using this method. Okay. Actually, you can skip the factor of 6, factor of 2 if you want. Directly try some number that you think that can be possible, but I think this is useful. Okay, this is useful, and actually you can use it, still use it until until you learn calculus, you learn other advanced mathematics. This is still useful. This finding the rational zeros, factor of 6 and factor of 2, this p over q. This is useful, and the card rule is also sometimes useful. Okay, and maybe we can also try another number here, negative 2, maybe negative 3. So 2, negative 6, 5, 15, 2. Oh, we got our zeros. Okay, we got our zeros. X plus 3, 2x squared minus 5x plus 2. Let's say we have this equaling 0 for now. Okay, just in case we are just dealing with the numbers first. Okay, so can we factorize? Let's check. Let's try to x. That's the only way it can be possible. We need to have negative 5 when you are adding. So you will have oh, it should be negative 1, negative 2. So negative 4, negative 5. Yes, that's correct, right? So we'll have, okay. So you will have 1 negative zeros, and this will be 2 positive zeros, right? So this is correct. This is our zeros. And then we will have the zeros are negative 3, half, and 2. This 0. Let me write this is zeros. Okay. And how do we make our conclusions? So this is not our answer. Our answer is based on the inequality. So we need to find the interval where the whole polynomials here will get at least 0 or positive or greater than 0. Okay. So we can make our line number. So I always suggest using line number. Okay. And you need to familiarize with the line number. This is it's so powerful, so useful. In my younger days, when I was still students, I also ignore the part of this line number, and I said not really important. We can look at the function. We need to find its positive 0, blah blah blah. But eventually, for some functions that are maybe a little bit complicated and maybe it is rational functions, sometimes line number will help you to get the confirmation, to get the clarification of the answers. Okay, so let's write all the things here. Negative 3, half, and maybe 2 is over here. Maybe negative 3 about there. Okay, and it needs to include the zeros in the interval because we need to make it greater or equal. So we are going to have close interval here, right? And then we check one by one. We check this one here, checking 0. Yeah, it's positive, right? Checking 0 is positive. And then checking 1, or maybe -4 first, maybe -4, -4, -4, positive, negative, -4, 4, 4, 64, 1 to 8, -1 to 8, 4, 16, -4, -52. Still, it's negative. Right? It's getting negative here. If we have 1, -2 plus 1 plus 13 plus 6. Okay, it's positive. And look for 3. 3 is negative, plus 9 plus 39 plus 6. Still greater in negative, so it will be negative. So we need to find the one that has equal 0 or greater 0. So we will have here. Okay. So this will be our answer. Oh, wait. Let me check one more time. Oh, wrong. This is the P negative, so we need to start over. Sorry. This should be, let me write the whole equations one more time. This is the right equation. Sorry. Okay, one more time. We check -4, -1 to 8, -4, 16, 52, 6, still greater negative. Check for 0, that is positive. Check for 1, 2 plus 3. Oh, it's negative here. Okay, sorry. And then look for 3, positive. Oh, it should be positive here. So the answer will be here. Okay. Sorry for the previous one. I'm using the wrong equations. This is a P of -x. So we need to find that the px is greater or equal 0. Okay. So the answer will be, so solution, we can write this and this. Or if you want to write in terms of this, also correct. That's also correct. Okay, let me give you another example and a few minutes to check and see how you can try to find out the inequality. Okay, if you have questions, you can write in your chat box. And for students who want to have more tutorials, have you contacted your calculus TA? Have you checked with your calculus TA whether he is maybe have some suggestion for you, or maybe has some maybe additional homework for you? Is there? Have you talked to the TA or not? Okay. Yeah, if you want to have like maybe more uh, learn, you want to understand more about the concept, you can ask your TA first. Maybe he has some suggestion, or I will ask my TA to give the students more, or to have additional requests from the students. Okay, because I believe you can have additional classes with your TA if you want. If you want, you can actually asking the TA to have another class, and your TA can uh, arrange another schedule for you if you want. That's actually, it can be done like that. Okay. Okay. Next question here. Let me give you another example and see can you solve it or not. Okay, let me give you a few minutes to check and to try finding the solution. There's only two sections in this one: the inequality, the polynomial inequality, and the rational inequality. Okay, so if we want to solve this, first we need to make it into one side. Okay, we need to find any x or any zeros that can make the whole polynomials negative, right? This is a negative, right? And if you look at the equation here, if you check the Descartes rule, so if this is a px, we'll only have one variation of change, so we will have one positive zeros. Okay. And if we check the oh, let me write here so that I will not take mistake again. That's our px. Let me write the p negative x. Right, that will be negative. Still same. This will be plus 12. This 4. And this will be 1, 2, 3. So we will have 3 negative 0 or 1 negative 0. So 3 or 1 and 1. So the fact that it has only one positive 0, that will have, or it will help us to find. So this will be start with 4 and 3. So factor of 4, factor of 3. And you need to divide this. Factor of 4, 1, 2, 4. Factor of 3, 1, and 3. So we will have plus minus 1, plus minus 2, plus minus 4, plus minus 1 over 3 plus minus 2 over 3 plus minus 4 over 3. Okay, it's quite long for the polynomials, so let's start with 3 minus 2 minus 1 minus 12 minus 4. So we start with maybe 1. Okay, it's not. Start with 2. Okay, I think this is our zeros. So we will have x minus 2. And then we have 3 x cubed plus 4 x squared plus 7x plus 2. Okay, let's say this should be equal to 0. Can we try to divide this? Okay, try again. Try to find the 3, 4, 7, and 2. Now we are going to look at the negative part. Okay, let's start maybe because I believe if we have this, our x cube is having at least x with some x squared, right? And it should be 1, 3, or 3, 1, right? When you look at this, there is a possibility that it will have a rational or a fractions, the zeros, right? The logic reasoning behind that, because it should be making 3. So let's check this out, this part here, and check the negative one, because we already finished with the positive. And the positive is only 1, right? Positive only 1. So it's really helping you narrowing the answer. So let's start with the maybe negative 1 over 3. So it's 3, it's negative 1, 3. Negative 1 should be 6, should be negative 2. Oh, we get the 0. So we will have x minus 2, x plus 1 over 3, and then this will be 3x squared plus 3x plus 6. Or if you would like, we can also write this in terms of 3x like that. And we will divide this all by 3. So we can have this. When you look at this, can we try to factor? No, right? So this is, again, it's called the irreducible factors. And in our case now, okay, we are not really including the complex. So we are only looking the real zeros. So the real zeros will be here and here. So this will be 2 and negative 1 over 3. Okay, now how we are going to solve our inequality? So we need to have this less 0, right? So we are going to look at the line number. Okay, and if you see the equation here, this always positive, right? You check 0, positive, check 1, positive, check the negative, because it has squared, it's always positive, and negative, it's half part, it's positive, right? It's always positive. So we don't need to worry about this. What we are worried about is this two part, this A and B. Because A, B, it can make the whole equation become negative. Okay. Now we are going to put the equations. First is -1/3, and then the other one is 2. And it should be an open interval because we don't want to be 0, because we need to have less 0. So we need to find the negative. We need to find the negative. Okay, try 0. If we try 0, it's negative. If we try 3, it's positive. If we try -1, negative become positive. So we are looking at this. So the solution is, or this. Okay. Any question? Any questions? Yes. If you have this kind of situations, the irreducible factors, you are not really using that zeros. Do you know why? Because basically, we only care for the one that makes it negative. Okay. And actually, if you have real zeros, that you can use. Okay. This part here. Okay. This part here. Aside from irreducible factors, there is another part that if you are using the 1 minus 4ac, right? 4, 2. This is 2. This is a complex, not real. So we are avoiding the complex. We just ignore the complex and focus on the real zero. Okay. Yeah, the assignment. I think the assignment, they have real zero. Yeah, they have real zeros. Most of them. I think all of them. You need to practically use the quadratic formula. Okay. And then don't worry about the quadratic formula. It's actually the formula that I actually hate because you know the formula, but it's kind of not really. It's really useful for some parts, but no, I'm not really like that quadratic formula. So the assignment is just to get familiarized with the equations, and then uh, it seems really messy with the numbers, right? But when I work on questions and design a question for you, I try to make really good questions that it is. If you look at the questions, the answer should be simple, short. But to find the answer, to find that simple answer, that you need to think. Okay, that is basically what I want to do in my question design. Okay, one more section here, and we finish the chapter 3. Okay, so this will be the rational inequality. So again, it's better to go for an example, a true example. Let me check my example. Okay, solve inequality is 1 minus 2x divided by, because I believe few of you are still struggling in this part, like finding domain, inequality. Okay, because in every part in math, you will always see the kind of questions. Okay, in calculus, in some sections in calculus, they will have this kind of questions. So if you're still struggling finding domain, range, solve the inequality, yeah, you need to get a lot more practice. Okay, not just practice, but practice that makes you understand. Okay, because sometimes when you have assignment, and you know the assignment may be coming from some textbook, like in calculus, or maybe this base of math, we have a textbook. And sometimes when you look at the website, maybe someone already make out the problem, and maybe you will see how to solve that. It's good for you, but I hope, aside from learning from the others, you try by yourself and apply the concept. Okay, and when you write the notes, write the formula by yourself, that is when you are actually learning. Okay, in math, and it's actually more impactful than learning in class. Okay, learning in class is just learning the concept, but for to understand the concept, you need to apply by yourself, and that is how you learn math. Okay. Okay, so how to solve this? Okay, so basically what we are going to do is we need to solve this way. Okay, do not cross this. Okay, do not cross this. Do not cross multiply. You will get a wrong result. Okay, why? You will change the domain. That is important, right? Okay, so we are going to solve this. So we are going to have a little bit of calculation here, and this would be greater than or equal 0. Solving this part, we will get 4. This will cancel, and 4 minus x squared. So we are getting that, and then we have this. I can write 2 minus 2 plus x, and then I can also yeah, that's is our factors. So this should be greater equal 0. Okay, now how to make this whole rational into our line number? So first, okay, let's look at this. Okay, it's already 9:50. A little bit more time here. We are getting the one that makes 0 are 2, x equal 2, and x equal negative 2. Okay, from the top part, from the numerator, from this one. Okay, that's the possible or the logic reason why it has 0, right? Because if this is 0 over some number, it's still 0, right? So we need to make this top one 0. So this will be our 0. And the one here, x equal 3 and x equal negative 1, when we are looking at this number and when we put this number inside, it will be undefined, right? So we need to avoid this. Okay, we need to ignore, or we need to make it not equal, so that our equations can be smooth, right? And probably there will be the vertical asymptote, as we are learning before. So we are going to write all of that. So write the negative 2, negative 1, 2, and 3. Okay, now we are going to check um, the line number. We maybe check 0, 0, 0 positive, check maybe negative 3 over 2, checking the number here. I think still positive. Negative, negative. Yeah, still positive. And checking the maybe negative 3. Negative 3 is, I think, this still also positive. Or negative. I think negative or positive. I think, oh, negative, negative, sorry. Negative, negative. Yeah, negative. It's negative. It's negative. 2 or 3. We can maybe 5 over 2, 5 over 2 to half. Negative, negative, positive, right? I think this is this positive or negative? 0. Oh, 0 negative. Sorry, sorry. 0 negative. This is positive. So this will be, we need to include negative 2. So this will be close, open, close, open. Okay. So negative 2, negative 1, and then 2 and 3. I think this will be also negative. So we need to find this part here. Okay. All right. Okay. I hope that's okay with you. We need to go to the feedback time, okay, because we don't really have much time. Or maybe if you want to look closely the solutions. If you still need to have some practice with this one, uh, the rational inequality, we can have more actually. But I think I will postpone until the next Tuesday for some maybe overview for 5 to 10 minutes, and then go to the new chapter, chapter 4. And because we have finished chapter 3, be prepared for another quiz. But I think not this week. I think next week. Okay, next week, the maybe the first week of November. Please check the Google Classroom periodically. I will prepare the quiz similar with last time using that platform, and I will adjust the time accordingly so that you can have more time to calculate. Okay. Okay. Let's start our feedback time. Okay, I think I already adjust the timer. I think yeah, and I hope it is okay with you guys. Okay, let's start. Let's start. Okay, 8 people. Thought we have 11 or 10, 11. Okay, let's just start. This is actually also in inequality problem. I think 2 minutes should be enough. I think. Okay, 20 seconds. Okay. Good, good. Okay, good, good. Question 2, 3, 2, 1, start. One half minute around. I hope enough. Okay, 30 seconds. Okay, 10, 9. Okay, I think one more person left. Okay, I just take random answer. It's 2, 3, 2, 1. Okay. 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 Okay, I think I will review this later. Okay, in the next week. So who will be the winner? Okay. Oh, again, Scarlett. Congratulations. Uh, I need to prepare some gift later when you come to Taiwan. Okay. So congratulations, and that will be the end of our lecture today. So thank you for coming. So yeah. Okay. End of our lecture. Okay. Thank you. Thank you again. Okay. Goodbye, everyone.